In this video, I want to talk to you about how to take the derivatives of general functions. And what I mean by that is what if instead of a problem just telling you that the function was x squared sine x, what if it actually had a reference in there to f of x? Like if you at some point in a problem needed to know what is the derivative of f of x, and this is easy, but the derivative of f of x is f prime of x. If some problem has a reference to g of x, the derivative of g of x is g prime of x. Like it's really a basic thing, but these problems are confusing if you haven't seen them before. So let's look at a few examples. So the first example, find an expression for the derivative of h of x if h of x is 3x squared plus f of x. So if someone said, hey, I really need to know what h prime of x is, you would just go, well, this is an addition rule because I have two things. This will be 6x plus, oh no, I wish I knew what the derivative of f of x was. The derivative of f of x is f prime of x, and you're done. You have found an expression for the derivative. And when I talk about taking the derivative of general functions, I just mean us not being afraid if there's an f of x or a g of x or some general looking function laying around. So here's another example of that, right? I want to find the derivative of g of x equals f of x times sine x minus x cubed. And I hope you guys are recognizing what rule needs to be used here, right? There is a product rule here. There's an f of x times a sine x, right? So if someone wanted to know what g prime of x was, I would begin by saying, okay, well, what's the derivative of the first thing? What's the derivative of f of x? Well, it's f prime of x. And then we would leave our sine x alone. Plus, then we would leave our f of x alone, and multiply by the derivative of sine x, which is cosine x. And then finally, the subtraction rule, we'll just have minus 3x squared. Right? So when all is said and done, the derivative of this thing is f prime of x, whatever that may be, so f prime of x times sine x, plus f of x, again, kind of whatever that may be, times cosine x, minus 3x squared. And there it is. Like, we may not know exactly what that thing is, but this is the derivative. Like, if 2 minutes later somebody told you, oh yeah, by the way, I know what f of x and f prime of x are, great. You would be in a position already to have that derivative worked out. And my last example is sort of one of my favorite examples, which means, hint, hint, something like this might show up on a quiz or a test, cough, cough, hint, hint, wink, wink. But, pay attention to this one. Right? So given that g of 3 equals 5 and g prime of 3 equals negative 2, I want us to find the equation of the line tangent to this thing. And part of why I like this is that on the surface, this seems crazy. You're like, how could I find the equation of a tangent line if I don't even know what the function is? And the thing that I would remind you of is we have a procedure. Let's follow it. Like, let's follow what we know how to do. If anyone ever asks you to find the equation of a tangent line, we always look for a point, and we always look for a slope. I mean, if you're feeling up to it, pause the video and see if you can figure this one out on your own. If you're not, I'll walk through it, because this may be a little weird. So how do I find the point? Well, I'm supposed to evaluate my original function at 3. Right? So that means I'm supposed to do 3 squared times g of 3. So f of 3 is 9 times, if only I knew what g of 3 was. Like, if only that wasn't some mystery function. If only I had some way of knowing what g of 3 was, and yet I do. G of 3 is 5. That means f of 3 is 45, and it means the point that I wanted all along is 3, 45. And now what about the slope? Well, to find the slope, I needed to find the derivative. I need to know what f prime of x is. Well, all I have to do is use the product rule on this thing. That'll be 2x times leave g of x alone, plus x squared times g prime of x, the derivative of g. Right? Now I need to evaluate my derivative at my value of 3. So that'll give me 2 times 3 times g of 3 plus 3 squared times g prime of 3. Notice all I'm doing is I'm just evaluate, I'm putting in a 3 everywhere that I have an x. Now I'm just evaluating. F prime of 3 will be 6 times g of 3, which was 5, plus 9 times g prime of 3, which was, if we look up here, that was actually negative 2. F prime of 3 is going to be 30 minus 18, which is 12. That's my slope. I already have my point. And so to find the equation of the line tangent, we just use point-slope form. Y minus 45 equals 12 times x minus 3. And there it is, the equation of the tangent line for a function that we feel like we didn't totally know. I mean, that function had a random, like, g of x thing in it. If you're given the right information, you can still work through those. I should mention that this problem is not just a favorite of mine. This shows up on the AP exam, this shows up on the IB exam. Being able to deal with sort of general or abstract functions is important stuff.